Now welcome to today's class. Today I want to take you through logarithm. So here with me I have a problem here, like log x base 2 plus log 2 base x is equals to 2. Now how can I solve this? So step number 1, you are required to look at the law of logarithm that will enable you to solve this problem here. Now the base law of logarithm states that if I have log a base b plus log b base a, the solution should be, if you look at the two logs, they are different because the first log has a base of b, the second log has a base of a, and therefore the law requires you to make both the logs to be having the same base, and therefore you are required to write this first log the way it is, like log, that is log a base b plus, now when you come to the second log here, for it to be the same as the first log, you are required to get the reciprocal of it. So you shall be having 1 over, then you just write the second log, that is this, the way the first log is, because we've gotten this reciprocal here. So I'll come here and say now log a base b. Remember, it is now log a base b, but not log b base a. So this is the concept I want us to discuss as per now. Yes, very important. Now this the same way I'll derive this problem to be the concept I've derived there. Now how can I go to the step? Now I'll have, that is log x base 2 plus, now remember I have 1 over log a base b. So here I'll be having 1 over the problem here after getting the reciprocal of it, so that it can be the same as the log x base 2. So it will be 1 over log x base 2 because I have gotten the reciprocal here. Then I equate it to 2 because the value there is 2. Now after this, you are required to say that let log x base 2, that is this log x base 2, because they are the same, to be any other number. So my best value here is y. So where log x base 2 is, I'll be substituting with the y, and here I go. So I'll come here, and because it is log x base 2 and here log x base 2 is y, so I'll come here and say y plus, it is 1 over log x base 2, and log x base 2 is what is y, so it will be 1 over y. So it is 1 over y is equals to 2. Now after reaching here, I'll now say that let me get the the LCM, sorry. So I'll be getting the LCM of 1, y, and y. 1 is just y. So I'll multiply each and every term by y. So I come here, I multiply by y, here I multiply by y, as well as here I multiply by y. So that this y will go with this to remain with y by y, that is y squared here. Then plus y had gone, so I remain with 1 here, is equals to y by 2, that is 2y here. So to rearrange this, I'll be having y squared, because positive 2y, if crosses the equal sign, it will be 2y, then plus 1, because it had not crosses, is equals to 0. Now when you reach here, you are required to use a product sum method. You can as well use completing square or quadratic formula, but as per now, let us look at let us use product sum as the simplest method here. So I'll come here and I'll get product sum, product AC, I'll have sum which is b here. So AC here, this one, the coefficient of y squared is 1, the coefficient of constant is 1, so 1 by 1, that is 1. Then b is the coefficient of y here, which is -2 here. So I'll come here and write -2 here. Now after reaching here, you are required to look at two numbers which when you multiply you get 1, but when you add them you get -2, and those numbers are -1 and -1. So after getting the two numbers, you are required to substitute it with b in this equation here. Yeah, so that comes the next step. So I'll have y squared minus, so instead of me having -2, I'll be having -y, that is -y because neg1 by y is just negative y, then neg1 by y as well is negative y, then I have plus 1 here is equals to 0 there. Now after that, you are required to group them into two so that you can solve the problem there. So when you group them there, you are required to get the common term here as well as the common term here, then you put them outside the bracket, and the common term here is y into, so y goes into y squared, y times minus y goes into y, that is 1. So when I come to the next bracket here, that is negative 1 because there is imaginary 1 here, so negative 1 goes into y, that is y, then negative 1 goes into positive 1, negative 1 times is equals to 0 here. Now after reaching here, you are, since the what are in the bracket are the same, you are required to take only one bracket, then those values outside the bracket you group them under one bracket, and that's mark the next step. So I'll come here and say y minus 1 here, alafu y minus 1 is equals to 0 there. Now after reaching here, you are required to equate, take the first bracket, equate to 0, get the value of y, take the second bracket as well, equate to 0, get the value of y. And since when you look at the two brackets here, the content within the brackets are the same, and therefore after getting the y within one bracket, you shall have just done. So that's, I'll be having y minus 1 is equals to 0 there. So when neg 1 crosses the equal sign, it will be positive 1 there. Now since I said here that let log x base 2 is equals to y, therefore I'll now come and say log x base 2 here, that is log x base 2, it is equals to y, and my y now is 1. So I'll come here and write 1 there. Now when you look at this problem here, it is under a logarithmic notation. So to get the final answer, you are supposed to write the problem here under index notation, and therefore the solution should be, assume you have log a base b is equals to c. To write this in the index notation, you are required to write a here the way that is, then b should substitute c. So where c is, you write b the way you have run that, then c now becomes the power, so c we write as the power there. So that's how we shall be deriving this. So my a here is x, so I'll come here and say x now. Then my b here is 2, so I'll come and say this one is equals to 2. Then my c here is 1, so I'll come here and write 1, and therefore 2 raised to 1 is just 2, and therefore my final answer is now 2. Now after working out the same way I've done here, you shall have gotten the value of x, and therefore the solution to the problem here under logarithm should just be the same way here. So this problem here normally bring a very big problem to students specifically, because deriving this problem here is always a problem. So please mark each and every step and the comments are made so that you can pursue this area. Otherwise, see you next class. Bye.